I became interested in aviation and flying from the time I was a small boy. My 12th birthday present was a flying lesson from my uncle. He flew small Piper Cub type airplanes, and although he wanted to take me a long time before, I wasn't allowed to go until I was 12, and on my 12th birthday, my present was to go flying with Uncle Coleman. And it took immediately, okay? I kind of fell in love with it, and he already was. And he didn't have much money, and I didn't. Dad died when I was 6. I worked part-time cutting grass, trying to get money and so forth. Helped Mama out with the groceries, okay? But we made a deal after my first flight. I kept back just a little bit of my money from cutting grass, and he held back a little bit of money from his paycheck, kept it secret from his wife. And on Sundays, we would put that money together. When we had enough money to fly at least a half hour, we'd go to the airport and fly. And so I started flying when I was very young. When it came time to graduate from high school and I was looking for a career, I decided that I either wanted to be a pilot or a flight instructor, okay? And being a physician was also in there also. I couldn't afford to go to school, and the programs that are available now to go to college were not available then. And so I started looking at the Apprentice School, and I wanted to come to the NASA Apprentice School. Well, the world was different back then, and getting into the Apprentice School here then was different than it is today. In order to get into the Apprentice School, you had to take a test. And before you were allowed to take the test, they gave you another test. You had to demonstrate that you were interested in aviation, and you had to have done something to show that you had an aptitude toward it and you had a genuine interest in it. And because I was able to demonstrate that I had taken flying lessons and I had built and flown model airplanes and a member of the Piston Poppers Model Airplane Club out here at Langley, I was allowed to take the test. And when I took the test, there were 340 people who took the test that day that were given in the activities building. And the test was on algebra, math, science, chemistry, physics, technical kinds of things. And of the 340 people, 40% of the people passed that test. Of that 40%, 8% got hired. They hired 28 of us out of 340. And the way you got your job placement in those days was the person who had the highest grade was called in and said, "We have these 28 positions. Which one do you want?" And they would select theirs, and then they would call in person number 2 and say, "We have 27 positions. Which one would you want?" Okay? And that's how it went. And when it came to me, I selected electrical, and I was fortunate enough to be hired and started work here at NASA. It was a different way to select people and a different way to get hired. And it was difficult to get here. They only hired a few. They didn't hire many. But they got generally pretty smart people. And so I came to work here in 1961 as an electrician. And I worked as an electrician for quite a few years, and at the same time I continued to take flying lessons, and I went to college at night, taking one course or another as I could do it. And somewhere in the early 60s, I want to say 1964, I was selected to go down to the Lunar Landing project. And before going to lunar landing, I was working in automatic control systems and trying to learn automatic control systems, and that's what I was gearing my studies to in school. I didn't take Englishes and histories. I took math, theory of equations, differential and integral calculus, physics, those kind of things. And when I went to lunar landing, I was one of the luckiest people in the whole world. I really was. We were going to the moon. We had a focus on going to the moon, and it was exciting. It really was. People would come to work early in the morning and go home late at night. On a few occasions, we'd go home the next day. And no one really cared. It really didn't. It was a great time to be there. The astronauts were going to come there, and they did come there to learn to land on the moon. And we really didn't know how to do that. You know, Kennedy told us to go there in 10 years, and no one had ever been there before, and we had to figure out how. And everybody worked together to try to determine, you know, what's the best way to go to the moon. And I say I was lucky, and I really was. I worked with some really great people. Hugh Phillips started that project down there. Let's see, Don Hughes was the chief research engineer, and I worked in then what became the Operations Support Division. We had computers back then, but computers started out as vacuum tube devices that would fill this room. Some of the rooms that might be even twice the size of this room had computers that couldn't match your watch or your tablet these days as far as computing power. And we were very project focused, and we were strapped for people. Facility engineering had 2 engineers down there that were working on the gantry systems and the lunar lander itself. There were some flight electronics control people who worked on the controls for the lunar lander, and there were instrumentation people from the research division, and there were engineers and technicians from all those different organizations. And then the spacecraft research branch was running basically the research project. Everyone basically worked for them, in support of them. I say I was very, very lucky. I was, because I worked with really brilliant engineers, and I worked with really smart technicians, and everyone was willing to help each other. It was the time of the Vietnam War, and there was a lot of issues in the 60s about the Vietnam War. And one of my personally fortunate thing was that we had one particularly brilliant engineer who was responsible for designing controls on the lunar lander vehicle, who was a 60s flower child, if you've ever heard the term. Okay? And he was concerned that going to the moon and going into space might help the war effort, and he decided he didn't want to do it anymore. And facility engineering was stretched for engineers at that time. They already had 2 other engineers down there. And this particular engineer decided he just wasn't going to work on it anymore. And he was given a project to design a control system on the vehicle, and he was given a deadline by which he had to have it ready. And we had preliminary reviews in those days. And I remember sitting around the table, and the leader of the support engineering staff, a gentleman by the name of Doug Church, very brilliant man, had many, many degrees, asked this particular engineer, said, "Well, did you bring your drawings in today?" And the engineer said, "Nope." He said, "Well, when are they going to be ready?" He said, "I'm not going to do them." And there was a little debate across the table. His superior was called, and they had some debate. And the next week, we had another meeting for him to bring his drawings in. And they got almost nose to nose across the table. And he said, "Where are your drawings?" I said, "I'm not going to do them." He said, "By God, sir, you'll get fired." He said, "By God, sir, I will not. I just quit." And he left. And a result of that was that they had no one to do the flight simulation package. And one of the engineers I worked with, a really smart older gentleman by the name of Curtis Chappell, asked me if I would consider doing the design for the flight simulation system, that he had worked with me long enough to know that I was capable of doing it. and understood the controls, and he talked to his boss, who talked to my bosses, and in the end I got responsibility to design the flight control system. And I was then, at the time, still almost a graduate apprentice. Another, for me personally, fortunate thing that happened was one of the flight control system engineers wanted a promotion and he couldn't get it, and I think he wanted to go to a GS-13. Promotions in those days were a lot different than they are today also, and he couldn't get the promotion. They told him that the job assignment that he had didn't warrant that kind of promotion. A 13 was a very high salary in those days. No technicians hardly ever got to a 10, you know. Most of them were wage grade, okay? And so he also took a hard-nosed attitude and decided that he wanted to leave. And a condition for him to get a new assignment was that he had to teach us how you set up and program the computers on the vehicle. And he did. He formed a class, and a whole bunch of people, mostly technicians and a few managers, sat in on the class to learn how those systems work. And again, I was luckier than you could ever imagine. I was taking differential and integral calculus at the time with a William & Mary extension, which is now Christopher Newport. And when I was taking the calculus, I couldn't figure out what in the world would you do with this. Well, when he put together, the engineer who wanted to transfer out, when he put together his course, he put together all the control systems and taught the course, but he taught the course in terms of the system equations. And no one in the class had a clue what he was talking about, except one person. Yeah. When I was taking the calculus courses, I had no idea how you would apply it. But I got the best education on how you would apply equations of motion and what you would really do with them that anyone could ever get. And because of that, I got to program the computers for the lunar lander. And when the astronauts came down, for the lunar lander, we were trying to determine how you would land on the moon. We didn't know whether the control stick would be best linear for linear flight controls, or whether it would be better to be an S-curve, how much deadband you would put in the control stick, and those kind of things. And so we had to try different settings. What we would do, we'd set it up and try different things, and our test pilots here would fly it, then the astronauts would come down here and see what they thought. Okay? And so I got to do that work. And I was fortunate enough that at that time I was graduating. I'd been a graduate of the Apprentice School, and they were now converting us from wage grade employees to GS employees. And most people came across automatically as a GS-8. Personnel was different in those days in that if you were being recommended for promotion, even if you were just graduating out of the apprentice school and being converted from a wage grade to a GS, your supervisor had to submit your job description. It went to personnel. Then they would go down and talk to you and ask you what you did. And you'd tell them what you did, and it had to match what was put on the job description. And then they would go talk to the research people you supported and ask them what you did. And if everything worked out, you got a promotion. Well, when it came down for my promotion, the personnel person came down, and my job description looked just like it did for the rest of us that were working together. And he said, this is what your supervisors say you do. Now you tell me what you do. He said, do you do these kind of things, and show me examples. And I said, yeah, I do those things, all of those things. He said, okay, then I need to go talk to the research staff. Is there anything else? I said, well, what about the other things I do? And he said, well, like what? And I said, well, I designed these systems on the lunar lander, and I programmed the computers. He said, oh, you mean they tell you where to set the dials and what to do? I said, no. That's not how it works. I said, they tell me what they want, and I come up with what they need, and we go fly it. And he said, can you give me an example? So I pulled out my drawer, and I showed him some drawings that I had made and some of my calculations. And so he went inside and talked to the researchers. And he said, well, when you make a flight, he said, how do you set up the computers? Do you tell Bud where to turn the dials and what settings to put in it? They said, no. So we tell him what we want in terms of control power and thrust and acceleration, and he sets it up. And they said, well, do you give him the equations? And he just writes it out. And he said, no, he derived the equations. And so the personnel specialist went to my boss and said, we're converting Bud over to GS-11. Okay. And that set things off. That did not fit. That wasn't politically correct. Okay. That would have put me making a little bit more money than my immediate supervisor, and as much money as a branch head in those days. And they couldn't do that. They said, no, we can't do that. That would stir up a ruckus. The unions would have a field day. We can't do that. And they said, then you have to take Bud out of the job. And long story short, they didn't want to take me out of the job. They probably could have, but they needed to find an engineer somewhere. And so what they did was they brought down a higher grade technician, gave him the responsibility. He went to the meetings. They told him what they wanted. He told me, I did it, told him, went and did the job. And they gave me a significant award. And not too long after that, I became a supervisor. It was a few years, but just before I was made supervisor, I was allowed to design the first set of solid-state controls for the 8-foot high temperature tunnel, and I designed the first set of solid-state controls for the boundary layer system at the 16-foot tunnel. But then I became a supervisor. We would come to work early in the mornings and go home sometimes 1, 2 o'clock in the morning, and nobody cared. I can remember going across to, there used to be a bar and grill across the street from NASA called the Dude Ranch, and we would send somebody over and they would take orders, and we'd get sandwiches 1 or 2 o'clock in the morning. They tied us over, and we'd be back at work the next day at 6 o'clock. You know.
Why didn't anyone care?
No one cared.
Why is that?
Because it was fun to be there, and everybody had their own piece. Everybody was assigned something to do, and no one wanted the project not to go because they weren't there or they hadn't done their part. Okay? Minus the flower children who quit the job. You know, we worked really hard. We did. We would come to work early. We'd go home late. We partied hard. We did. Typically, I won't say once a week. Well, at the end of about every week, we used to have parties at the activities building. We'd go over and have a few drinks on Fridays after work. And maybe every month or 2 months, we'd have a big party where people would come, they'd bring their spouses, we'd dance. There would be bands there, and we all had a really good time. It was a very close-knit group. It was fun, you know, when the Apollo 13 thing happened, you know, we knew those people, you know, and we watched. One of the things that made it exciting being there was that we were getting ready to land on the moon. Okay? And we got to meet the astronauts. We got to fly the vehicle. It was different. Okay? It made a lot of noise. and we set up a really good simulation. Simulations in those days weren't like programming computers. We had the actual flight vehicle, and it was powered by rocket engines. And we wanted to simulate the landing on the moon. And we learned some things by accident. And one of the things that I remember that I thought was particularly unusual and a little bit funny was that we built the actual lunar lander surface underneath the gantry with the craters so that the astronauts could practice moving around the craters and finding a good spot to set the vehicle down. And we had a large bank of lights at one end of it so we could simulate the lighting and the angle of the sun when they approached there, so the shadows would all be the same. And then one day it rained, and our craters filled with water. And when the vehicle came down, the heat and blast from the rocket motors turned the water to steam instantly, and it blasted out under the vehicle, and the pilot lost sight of the landing surface and had trouble landing, so we aborted the flight. We came up with a way to do the landing. We put a 67-inch stick below it, so as the stick hit the ground, it flashed the light in the cockpit, and the pilot closed the throttle and landed the vehicle. And when Neil Armstrong went up and did the first moon landing, as he approached the lunar surface, if you look at the videos, you'll see the fine powder dust blowing out from under the vehicle, and it became difficult for him to land, okay? And then when he came back, he was asked about the lunar landing experience. And he said, well, you know, when we landed that time and all the steam blew out from under the vehicle, he said, it looked just like that. And so we had earlier gone through and drilled a whole bunch of holes in those craters to drain the water out from the rain. We went back to patching the holes and putting water in them for the future flights. Okay?
That's where you learn
part of the
things.
simulation that evolved, and it wasn't really designed. Okay? Some of them had really neat personalities. They would come out and talk. One of my favorites was Fred Hayes. Fred Hayes was a very pleasant gentleman to talk with, and Fred Hayes had a tremendous sense of humor. In addition to landing the lunar lander on the moon, we also tried flying different vehicles down there, because once we got to the moon, we wanted to explore, and we didn't know how we were going to get at that time around the moon's lunar surface to explore, to get away from the vehicle and then come back. And they were looking at vehicles, rovers that you could ride, and they also were looking at flying platforms. You may have seen a James Bond movie where they had the backpack with the rocket-powered thing. Well, that was first flight tested here. That was going to be one of the methods they were considering to land on the moon, and we test flew that rocket backpack with the astronauts here under the gantry. And Fred Hayes was flying that backpack, or one similar to it, and as a possible lunar excursion device. And when he fired the rocket motors, he lost control of it and fell over on his side, and he was wound up spinning in circles on the ground. The rockets were going, and he was spinning in circles on the ground. Everybody was excited trying to get the motors shut off. And over the speaker system, Fred starts singing. He starts singing, "Tie me kangaroo down, boys, tie me kangaroo down." And just amazing people, you know. It was a fun place to be. It really was. And I remember one time in particular, we were getting ready for the astronauts to come down for a training session, and we had some practice flights prior to them coming down to make certain everything would work. And we had a hard landing incident. We had one rocket, a switch for the main rocket motors that was adjacent to the computer power switch. And the rocket motor switch had a red guard over it. It was a little thing you had to lift up in order to operate the switch for the main thrusters, but the computer power switch didn't. And when he got ready to land, he intended to shut off the main rocket motors, and instead of hitting the switch for the main rocket motors, he hit the switch for the computers. So the computers died before the rocket motors did, and then the rocket motors didn't know where they wanted to be, and they blasted off. And so we got a hard landing incident out of that, and it messed up the contacts in our computers. Again, computers in those days, these were the most modern computers you could get, and they were analog. You had to patch wires from one amplifier to another one using resistors and capacitors to describe the circuit that you wanted, or control algorithm that you wanted. And they were all hardwired, and the amplifiers themselves were maybe this long and this wide and about that tall, and they slid into racks, and it damaged the contacts on some. And so we started getting various signals that we didn't intend to get when we tried things out right after the hard landing, and realized that what had happened was the jolt had messed up the contacts where you plug the amplifiers in. And we were given the instruction, well, the astronauts are going to be down tomorrow. Fix it, have it ready to fly. Well, a whole bunch of people got together, and I was leading that particular effort, and we were told, have it ready to fly tomorrow morning. So the answer was, yes, sir. And so everybody that was working on the controls got together, we formed a plan, and we pulled out every amplifier and every computer and unwired it and put in new connectors, and we rewired the entire computer that night. We left here about 5:30 in the morning. We were back around 6 or 6:30 in the morning. I went home, I took a shower, changed clothes, and came right back. I live in Pocosin, so it was a 10-minute trip to go out. And I was gone long enough to take a shower. When I came back, we got together, and the supervisor said, I heard you guys worked all night. I said, yeah. You said have it ready to fly this morning. And we were proud as punch, the whole team was, okay? And we got chewed out for working all night and coming back the next day. I got so mad, I went to the shipyard and applied for a job. And they offered me one, and I said, what in the heck are you doing? Go back. But we got chewed out because we worked all night and came back the next day. But they didn't send us home. We did stay there, and we finished the next day. But we weren't allowed to work all night again. It was different. It wasn't just us at Lunar Landing. The people in the wind tunnels were doing some great things. My immediate supervisor, Pat Mason, okay, when I was at Lunar Landing, he was a first-class man. He put in the control. I don't know that he designed them, but he at least installed them and set up the controls and did the operations for the Rendezvous docking. When we went up on the rocket, they carried the limb in the rocket. They pulled the limb out, turned it around, and then the capsule had to dock with the limb. And then when they got to the moon, they went into orbit on the moon, and 2 astronauts would get in the limb, and they would undock, and they would land, take the limb and go down to the surface of the moon and land. Then they had to come back and dock. Well, the concept for that docking was practice over here on Building 1244, and Pat Mason and a team of people worked together with some research engineers and the astronauts, to practice docking in the capsule over in the hangar. And they built a simulator, and it was suspended by cables over in Building 1244, and a lot of that work was done. So while we were learning to land on the moon, they were also practicing rendezvous docking over in the hangar down at Kennedy, I believe it was it Kennedy or Houston? I think it was. Maybe it was Houston. They had another version of the lunar lander simulator we had here, except it was a free flight model that was powered by a jet engine, a big jet engine and rocket motors, and they flew that down there That's the one that Neil Armstrong had to bail out of. It crashed. Neil was a really neat guy. He went up for a test flight early one morning and had some control issues with that particular one, lost control of it and had to bail out. And it crashed and burned. He came down by parachute and was in his office by 8 or 9 o'clock that morning, sitting at the desk, and someone walked in, as I hear it, and said, "Neil, didn't you have an accident this morning and have to parachute?" Yeah, not a big deal, okay? It was a matter of the daily work routine. It wasn't a big deal to Neil. Then our simulator became really important because then it was the only one they had to learn to land on the moon. But it was a group effort, amongst the centers, and it were lots of projects. We were doing that there. They were doing rendezvous docking over in the hangar. They were doing capsule ablation testing in some of the wind tunnels out here, making certain that it could survive re-entry, and looking for ways to improve that. Lots of neat work. It was a fun place to be. I did not want to stay homesick. It was something going on. I wanted to be here, and I wasn't the only one. Everybody here was that way. The guys in the wind tunnel, the people in the hangar, the astronauts, the engineers, the ones who didn't want to support the space effort left. but people were fighting to get here. It was, hey, I want to be a part of that. And we had a long list of people who wanted to come here to work as an engineer or to be a technician or a mathematician. Our very first computers out here were women. Most of them were women, maybe a few men, but they had degrees in mathematics and they were the computers. It was before the days of digital computers, and we recorded data by charts. It was a graph paper that would roll on a chart and little pins that would move, okay? And the deflection of the pins was proportional to the deflection of a speed or a thrust or the movement of a hand controller, and they were all calibrated. And so, for instance, if you wanted to know how much thrust you got for the movement of the hand controller, when the astronaut moved the hand controller, a little chart recorded that on the line, and the thrust was recorded by accelerometers, and it would have its own line, and the computers would take these long charts with straight edge papers and rulers, and measure the deflections and say, well, for this much stick movement, we got this thrust, and it followed, and they would plot each data point and draw the curves to make certain that we were getting what we wanted, or find out if we didn't get what we wanted, okay, and tell us, no, for this you got that. And so they actually took pen and pencil, and they would draw the lines if they wanted to know what the velocity was. For instance, when we reached a certain point, they would measure the rate of change by looking at the angle of the line made across the graph paper, because the graph paper moved so many millimeters per second or whatever. And so they would take the number of millimeters per second and the change of the amplitude per second and come up with the speeds and accelerations. They did that manually on every test. They were swamped with data. Sometimes it would take a week or so to get back all the data from a particular test. And so that's why they were called computers, because they did. They had mounds of paper or mounds of recordings. Later on, when we started getting some digital data, they would take the digital data and then do the same thing. It was not till later, when we were able to do digital computing, that the computers actually did the computing. Their official title was computers. We had two at Lunar Landing. Marna Mayo was one of them. Jackie Miller was another one. She was the secretary, and I think she started working as a computer over at the 7x10. Bless her heart, what was her name? It was a lady over at the 7x10 wind tunnel, which is where 14x22 is now. And she was there for many years, taking the data, or developing the data from charts and graphs. They weren't many, and they were busy. And they were like everyone else, you know. They need this data, They got another test to do. They expect this by a certain date. They'd show up here sick. They'd come to work. There were no differences there. Lots of times we needed to do something, we didn't know how to do it. And we designed and made what we needed to do whatever it was we had to do. Many times a piece of equipment, you didn't buy it because it didn't exist. So you figured out a way to make one, and you went and did it, okay? And you did that in days when computers were drawing lines off of charts, and doing hand calculations. Imagine what you could do now if you were given the same kind of job with the computers that you have now and the equipment that you have now. I would come back to work here for free tomorrow, okay? If somebody said, we're going to go back to the moon and we're going to develop a new technology to get there, and we don't know what that's going to be, but you're going to have to tell us, but it's got to be a lot more efficient than what we've got now, okay? And we'll give you 10 years. You know what? I believe you could do it, okay? All you have to do is come up with a project like that, give it to the people, and they'd do it. Just give it to them and let them go. That's what they did then. That's what they do now. This place started, back as NACA, and again, that's the way they gave the word. Congress actually told NACA what they want them to work on. We want you to work on this, and you didn't work on anything else. You worked on that, and you had the staff to support that. And when World War II came, other countries had surpassed us in aviation. And when we got into World War II, the fighters and aircraft of other countries were outperforming ours. And so that's one of the jobs Full-Scale Tunnel got. We put whole fighter airplanes in there and flew them in the wind tunnel to find out what we could do to make them faster and more maneuverable. People like Dick Whitcomb, Bob Bales, Bob Champagne, Jack Reeder, all brilliant people, all neat people to work with. I remember one particular story, and I don't know if it's true, but I believe it to be true. It was told to be true. I was told that personnel had to come over to Dick Whitcomb's office and ask him to cash a paycheck. He was so busy and involved in his work at at Dick Whitcomb's wind tunnel, okay, TTT, that, no, it wasn't TTT, it was the Transonic Pressure Tunnel. But it was known as Dick Whitcomb's wind tunnel. That was his wind tunnel. And he was so busy with his work, he didn't have time to cash his checks, And I was told he had a desk drawer crammed full of paychecks that he just had not cashed. And they told me he had to cash a check when he was messing up the books. I told this story, and I'm going to tell this one again because it was really neat. I went on a tour up to the Garber facility in Washington, where they take some of the aircraft and refurbish them to put them in the Smithsonian Museum. And we were up there on the tour, and it was Jack Reeder, Bob Champagne, Bob Bales, let's see, Dick Whitcomb, and a few others. And we were walking through the facility looking at some of the airplanes there. And I recognized some of them as airplanes that were being flight tested when I was an apprentice here. When I first came here as an electrician, I worked over in the hangar as an electrician in my first few years, and or part of my first few years. And I used to look out the door while they were flight testing some of those vehicles. They were vertical takeoff and land type airplanes. watched an accident or two while they were doing that, and it was kind of neat just to watch them do it. Yeah. And those airplanes were up there. And I said, well, that is really neat. And we had a docent going along with us telling us about the different airplanes. And we came up to, I think it was the P-38, the twin-engine fighter in World War II, that we worked on here in the wind tunnel. The P-38 was one of the first of that vintage airplanes that would get fast enough in a dive, not in straight level flight because it couldn't do that, but in a dive it would get fast enough to where compressibility was an issue, and it'd start to develop a shock wave as the airflow over the wings approached the speed of sound. And the shock wave would block the airflow of the controls, and the pilots would not be able to pull out of the dive, and we lost some pilots because of that. And so they brought that airplane here to see if we could develop a fix on it. And Bob Bales and Dick Whitcomb were over there looking at that particular airplane, and there was another engineer that had worked on it, and I can't remember his name to save my life, but they were looking at a slot in the bottom of the wing. And the docent said, what are you looking at? And they said, we're looking at the flap. And he said, no, that's not the flaps. The flaps are on the trailing edge of the wing. Airplanes have flaps on the trailing edge of the wing to help them slow down for landing. He said, nope, not this airplane. He said, this airplane's got a flap that extends out of the bottom of the wing. So you see that slot right there? He said, we put that there so to slow the airplane down on purpose so it could get slow enough and break up the shock wave and get it slow enough to where the pilots could pull out of a dive, because it was the first that would go that fast. And then when you extended that would allow the pilot to get control and solve the control issue. And the docent said, well, gee whiz, I didn't realize that. He said, what are those guys looking at? And Bob Champagne and Jack Reeder were over looking at the vertical takeoff and land airplanes. Jack was standing there with his usual little short smile, and Bob always had a great big grin, and they were talking about those particular airplanes. And he said, what are those guys looking at? And one of them looked at the docent and said, well, you see that guy standing there pointing at that airplane right now? And he said, yeah. He said, well, you see the name painted on the top door of these airplanes right here? He said, that's him. Made me proud to be there. It did. Worked with some really great people. It was hard not to really enjoy coming to work. I did. I flat enjoyed coming to work. It was fun, Becoming a supervisor and eventually a division chief, that was a neat accomplishment, But doing the work and being with the people was the most important thing. Even in that position, watching the people to do the things that I had done before and giving them the tools to do it, that was still fun. It quit being fun when it got to be politics, okay? But the people here can do some good work, and there's still a lot of good people here, Some of the people that I worked with back then are still here,
Huh? I'm still here.
Yeah. Davey Wyman's still here. Davey Wyman's doing some, as I understand it, he's a contractor here working, I think, on the compressor station. Davey Wyman was one of the support engineers at Lunar Landing. Okay? Yeah. Did the ALDEF project. He worked on the valve for the ALDEF. Brilliant people. Okay? They designed the facilities and systems that allowed the test conditions for the people like Dick Whitcomb and Bob Bales to work, and people like Jack Reeder and Bob Champagne would fly the lunar lander vehicle or some of the airplanes, and they would come back and say, it's fine, but you need to do this, and you can fix that airplane, or you can fix the lunar lander, and it'll handle better if you do this, you do that. And those people and the technicians that supported them, just went out and did it. You need to do this, you need to do that. We got together, we did this, and we did that, and we had a neat project, And what What the whole nation didn't realize was that when we started that, you wound up with solid state radars, microwave ovens, watches, okay, handheld computers, and they all evolved out of all of that. You know, when I started here, we had vacuum tube controllers and vacuum tube computers, and my first courses in electronics were in vacuum tube technology. And before I could finish that, they were too big and they were too unreliable, and we needed something better, and so a transistor was developed. And then we had transistor amplifiers and transistor controls and transistor computers, and when we were learning that, they were still too unreliable, and they still took up too much space, and they didn't have enough control power, and so then we came out with integrated circuits. And integrated circuits took up too much room and took up too much power, and we needed something a little bit better than that so it could be lighter and faster and more dependable, and we came up with the microchip and the microcomputers, okay? And it has evolved exponentially. Okay? And because of all of that technology, because Kennedy said go to the moon in 10 years, it happened. The neatest thing was that when we did go to the moon,
20 seconds
that it wasn't just us that celebrated, okay? It was the entire world, okay? All of us at Lunar Landing were there celebrating. We were watching, you know, we may not have been here, we were at home. Matter of fact, I know I was at home watching it on TV, but to just think we were a part of that and we helped that happen, okay? That was just the neatest thing, but it wasn't just us. It was Russia, China, France, England, the whole world celebrated what we did. And it kind of like brought the whole world together, saying, gee whiz, what an accomplishment. And it wasn't, you know, the Cold War was forgotten, okay? All the differences were forgotten. This is a great thing for mankind. You know, when Neil said those words, okay? One small step for man, one giant leap for mankind, okay? The whole world felt that. And it wasn't just NASA Langley. I seriously remember when there were lines of people out the gate just trying to get here, okay? And getting here was hard. But it was worth it when you did. One of the neat things was that when you were assigned to a project, whatever it was, whether you were working in a laboratory or if you were working in a wind tunnel or a lunar landing, you knew what the end goal was. Everyone knew what the end goal was. Everyone knew what their part was. And everyone was willing to help the other person. I mean, I received so much information, okay, and knowledge from the engineers and the scientists I work with, okay. And they were anxious to tell me what they were doing so I would understand the entire impact of how my part played into it, you know. And when you came to work to do work, you got an education while you were at work, you know. Yeah, I got some educations that weren't intended, okay. I was very fortunate for me, okay. But I got probably as much education from engineers who were intending to give me the education because if I understood it, okay, then I would give them a better product for my part. I wanted a degree, never got it. Matter of fact, I'm seriously considering going back to school right now, okay? I'm having some conversation with some friends who are running some programs at university, one at Liberty University and one at Hampton University. Who have said, well, Bud, why don't you just go ahead and do it, okay? And so we're having this conversation right now. As a matter of fact, before the week's out, I may be getting transcripts to either go back to school at Hampton University or Liberty University or both to finish a degree, okay? But I wanted a degree, but again, back then, the programs weren't available, and I couldn't afford it. I married at a very young age, okay, had kids. Had a job, and I couldn't afford to go back to school. Now, I will say, okay, that some of the staff that I worked with, okay, Doug Church, Davey Wyman, Charlie Marucci, Curtis Chappell, the engineers that I worked with, many of them encouraged me to go back to school. Okay? So you need to go back to school. And so I was doing it as best I could, taking a class at a time. I was not smart in some ways in that I didn't take Englishes and I didn't take histories. I was interested in technical things, okay? And I knew that the calculus and algebra and physics would help me in my job. When I was at Lunar Landing, the fact that I knew about pitch, roll, and yaw because I was a flight instructor, okay? And then I understood computers because I had taken automatic control systems, you know, through a special course set up at ODU, you know. And I had worked in the early years as a technician working control systems in the wind tunnels. All those things came into play, knowing that, you know, the more I learned about math and science, okay, the more it would help me with my job. And in the end, I would get a degree, but I never got around to taking the Englishes and the histories and those kind of things. I was working with the chief operations engineer, a gentleman by the name of Max Good. Max Good ran the operations at the control room when we flew the lunar lander. And he came to NASA as an ex-Navy pilot. He flew the original Phantoms off of carriers. And Max Good was a really smart man, and he encouraged me to go back to school also. And he said, you need to do that. And back then, the astronaut program was going to expand. We had the original 7, the Mercury 7. And they wanted more astronauts to fill the program. And so, but we were on a hiring freeze. We couldn't hire from outside. And so they determined that if we were going to get more astronauts, it had to be from within NASA or another government agency. And so the call went out for astronaut applicants. Max encouraged me to apply. And I pulled out the application, and he and I sat down and went over it, and I met all the flying requirements, okay? And I had everything but a degree. If I had a degree in basket weaving, I may have been able to apply to be an astronaut, okay? But because I didn't get the degree, okay, I didn't quite qualify. In the early days out here, if there was an engineering type job, many times they would say you had to have a degree in this or the equivalent, okay? And in the early days, because of the maths and so forth that I had taken, okay, it was considered to be almost the equivalent, okay? But that didn't work for astronauts, okay? And so I kind of got mad at myself at that period of time that I had not taken Englishes and histories and gotten a degree, because I think I may have had at least just a little chance of being one of those astronauts. I would not have traded this career for anything, would not, okay? It was fun. And, you know, where else, okay, could a person graduate from high school, okay, not finish a degree, okay, start as an apprentice electrician, okay, wind up working on a project to go to the moon, okay, wind up leaving here, going through all areas of management up to a division chief, okay, the largest division at the center, 413 civilians, 375 contractors, running all the wind tunnels and labs. We were running 47 wind tunnels when I left here. 47. Where else in the world, okay, could you do something like that? The thought behind the way we worked in those days was we were here because there was a research project to do, okay? And they didn't bring research projects here because we were here. We were here to support the project. And so there was a research project that had to be done, and there were research engineers, scientists type people. You know, we had a handful of really brilliant people. We did. I mean, super brilliant people. And then and some of them are still here. You know, there's a few of them are still here. And they used to say that, you know, you had the scientists, and the scientists could keep 4 to 5 good engineers really busy, and a good engineer could keep 10 to 15 technicians busy, and that's the way it worked, you know. And you formed a team, and you went and you did a project. It wasn't that one person did anything. And you kind of evolved, you know. You evolved, and you did what you had to do to get the job done. And it was really fun. It really was. They gave you something to do, and they left you alone to go do it. When I left here, I spent a fair amount of time as division chief. When I left here, I was chief of what was the Operations Support Division and became the Facility Systems and Support Division, FSSD. But we were responsible for running all the wind tunnels, all the laboratories, the infrastructure at Langley, all the utilities. I had 413 people in my division, and with a contract support staff of about 375. So we were up in the 700s for the Operations Support Division, FSSD. And my last few years I spent defending why we had a technician workforce. Okay. That never occurred back in the early 60s and 70s. Okay. There was no question about why we had a technician workforce and why we had an engineering workforce. Okay. We had it because we were supporting a project. Okay. And if there wasn't a project, we wouldn't be here, you know. And so we were happy to see new projects come along. As the projects built, we hired people. Then the projects started going away. There weren't as many. And then that gets into the political arena, and there's no need to go there. You know? But it was a different world. No one had to defend while they were there. They didn't have time. There was work to do. After I worked for the Lunar Landing project, and that was winding down, I was given the job to design the first set of new solid-state controls for the 8-foot high temperature tunnel. I went over there and worked and learned the control systems there, and then started working on the design to replace. They were vacuum tube amplifiers, and come up with a design to replace those with new solid-state systems. And along that same time period, did the control system for the 16-foot boundary layer. And while I was finishing the design for the 8-foot high temperature, they decided I ought to be a supervisor. And then it evolved, and I went from a supervisor to a section head, and a section head to a branch head, and then retired from here as a division chief. But wouldn't have traded the career for the world, would not have. And during all that time, I still played airplane pilot. I worked part-time as a flight instructor and charter pilot. I did a little teeny bit of test flying for NASA. I was one of the few people who wasn't a test pilot who had sign-out authority for the research airplane, because I did some research test flying in the GA airplanes for them. When I told you earlier that we worked hard and we played hard, we would have parties. And when we had parties, we really did. Okay? And as we would come to work early sometimes and stay real late, sometimes when we had at parties, we stayed late. And her father-in-law, Pat Mason, my supervisor, you know, we were all friends, and there was going to be a party on a Friday night, and I didn't want to go because I wasn't good at drinking. I wasn't. Okay? 2 beers would get me drunk. I'd start thinking of funny things to do after 2 beers. I'm not too much different than that today. And Pat, he liked a beer, you know, and Pat was good at partying. And he said, "Boy, you going to the party?" I said, "Pat, I would." I said, but I called Jean, my wife. I said, she said, I can't go to something that she really has to do. Okay? And I said, and I've got to go with her. I said, I can't go to the party. And he said, boy, you going to the party? I said, Pat, I can't. Gene will be mad. I'm going home. Well, it was about 5 minutes before quitting time, and I was in the trailer rolling up my drawings. We worked in a trailer just outside the building, and Pat walked in the door along with a couple of the other technicians that we worked with. Again, we were all friends and teams. And he said, grab him. Okay, and I was sitting in one of these roll-around chairs, not too different from this one. And they held my arms down and took tape, and they taped my arms to the chair. Okay? They put tape around my body and slapped tape across my mouth so I couldn't make a noise. And in the back of the trailer, we had an electronics parts room. Okay, they rolled me into the parts room, okay, and shut the door, okay, for the last 5 minutes of the day. And then they waited until everybody had left, okay. They opened up the door, they rolled me out of the trailer, got me to Pat's car, cut the tape off my arms, they put me in Pat's car, and off we went to the party, where we both proceeded to get drunk, okay. And we had a hell of a good time, okay. But
Did you get in trouble when you got home?
no. No, a part that I left out was that when Pat walked in the trailer, I said, Pat, I can't go. He said, yes, you can. I called Gene. Gene said, it's fine. Said, you never talked to her. Okay. Said, you're going to the party. Okay. And that's when the tape started flying. Okay. We always had a good time. We had a good time whether we were working or whether we were playing, but we were whichever one we were doing it hard. We started well with rockets and jet planes and so forth, and we went to the moon, and we were in the process of evolving from there when we quit, and we quit. I would like to see us get going again. I would come back and work for free. I would be here at 6 o'clock in the morning. I would work till late hours at night, okay, at my age, okay, just to be a part of that one more time.